Welcome friends to my YouTube channel Sommo Physics. On my last lecture, I have discussed the binding energy of an artificial satellite and also weightlessness. That is the reason why an object or a person inside an artificial satellite is in rest weightlessness condition. Yes, in my last lecture I have discussed about this. Now few days ago one of my friends told me to discuss about the basic differences between natural and artificial satellites. What are the basic differences between natural and artificial satellites? Okay, so first of all I will discuss it. So let's proceed. Now there are so many differences. First of all, that we all know that natural satellites are created by nature. On the other hand, artificial satellites are man-made. Okay, this is the first one. Natural satellites are created by nature and artificial satellites are man-made. Number two is that the natural satellites are made up of natural elements like water, dust, mineral, etc. Whereas the artificial satellites are made up of metals or electronic materials. This is the second one. The third one is that natural satellites will not be able to communicate with the instruments on Earth, whereas the artificial satellites will be able to establish communication with the instruments on Earth. So this is another difference. Okay, now in case of a natural satellites, their size is so massive to stay in the orbit under the influence of gravity, but artificial satellites don't satisfy this condition at all times. Okay, so these are the basic differences, that natural satellites are created by nature whereas artificial satellites are man-made. Natural satellites are made up of natural elements like mineral, water, dust, whereas artificial satellites are made up of metal and electronic materials. Natural satellites will not be able to communicate with the instruments placed on Earth, whereas artificial satellites will be able to communicate with the instruments. And we also see that size of natural satellites are so massive to stay in the orbit under the influence of gravity, but artificial satellites, this does not hold good for artificial satellites at all time. Okay, so these are the basic differences. Okay, these are the basic uh, differences. And another difference one can say that natural satellites will cannot need any power from outside. Okay, natural satellites don't need any power from outside, whereas artificial satellite needs power, and power must be supplied by small nuclear reactors or the panels of solar cell. These can provide power to artificial satellites. Okay, so these are the basic things or basic differences between a natural and artificial satellite. Okay, so with this lecture our first chapter of classical mechanics is finished, that is the central force and planetary motion. We have already finished this chapter. Now from today I will start my second chapter, which is gravitation. So before starting gravitation I would like to tell you few important terms that you must know before starting gravitation. Okay, so what is it? Now in case of a central force and planetary motion, I discuss about few forces. Okay, and we have to recapitulate these forces before starting the gravitation chapter. Okay, so let's proceed. Now we know that there are four type of forces exist in nature: gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. So what is gravitational force? We all know it. This is the weakest force in nature, and this force is always attractive. Okay, and it is applicable for heavier bodies only. That is, we can feel it in case of heavier bodies. For small bodies, this force cannot be experienced. Okay, and this is an inverse square law, inverse square force. That is, F is proportional to 1 by r square. Okay, so these are the features of gravitational force. This is the weakest force in nature, and this force is always attractive. An inverse square force, that is F, is always proportional to 1 upon r square, and it is only applicable for heavier bodies. That is, the force of attraction can be experienced only when the mass of the bodies are large. We cannot feel it for smaller size masses. Okay, this is the first. Now second is that electrostatic force. What are the basic features of electrostatic force? Number one is that this force is also an inverse square force. How? From Coulomb's law we know that the force between two charges are 1 upon 4 pi epsilon naught q1 q2 by r square. If you take, that is, F is proportional to 1 by r square. This is also an inverse square force. The second point is that this force can be attractive or repulsive depending upon the sign of charges. That we all know. If we take similar charges, then this force is repulsive, and if we take opposite charges, this force is attractive. So depending upon the sign of charges, this force can be both attractive or repulsive. Okay, now, and another thing is that strong nuclear force. What is the definition of strong nuclear force? Okay, now what is the definition of strong nuclear force? Now we know this force is used to explain the stability of the nucleus. Okay, now we know that protons inside the nucleus are repel each other. Protons inside the nucleus are repel each other. So we cannot explain the stability of the nucleus unless we assume that the nucleons inside the nucleus are held together by strong attractive force that binds these nucleons inside the nucleus. So this strong attractive force is known as the strong nuclear force. Okay, due to the repulsion property, the protons can separate each other, so we cannot explain the stability unless we assume that the nucleons inside the nucleus are held together under the action of some attractive force that binds the nucleons together. This attractive force is known as the strong nuclear force. Okay, and there are three type of interactions available inside the nucleus: proton to proton, neutron to neutron, and proton to neutron. And the strength of three interactions are same. This is a most important point. Strength of three interactions are always equal. Okay, now the last one is that weak nuclear force. This is a short range force and comes into play for a small time intervals. For example, the common example is beta decay, where the decay products are lepton, where the decay products are leptons. Okay, so these are the basic things that you must know. The brief description about the four forces that exist in nature. Okay, now another thing, in case of the second question of gravitation that arises, that what is gravitational field and what is field intensity. This is the another question, that what is gravitational field and field intensity. Gravitational field means the space around an object or a body within which its gravitational force of attraction can be experienced. That is, the region within which the force of attraction can be experienced is called gravitational field. The space around an object or a body within which its gravitational force of attraction can be experienced is called gravitational field. The third term that arises, what is field intensity? We are familiar with this term in higher secondary, that field intensity at a particular point is defined as the force experienced by a unit mass placed at that particular point is called field intensity. Field intensity at a particular point is defined as the force experienced by unit mass placed at that point. Okay, so this is field and field intensity. And another term we also familiar is gravitational potential. What is that? Gravitational potential at a point is defined as the amount of work done in taking an object from infinity to a particular point in the field is called gravitational potential at that point. Amount of work done in taking an object from infinity to a particular point in the field is called gravitational potential at that point. Now, these are the basic things we have to learn before starting the gravitation chapter. Now, in my next class, I will discuss about the gravitational potential in details. Okay, so in today's lecture, I told about the basic differences between natural and artificial satellite. I told about the four forces existing in nature, and I also discuss about few terms that you are already familiar in your higher secondary level, that is gravitational field intensity, gravitational potential. Okay, so in our next class we will discuss about the gravitational potential in details, and also we take few examples. Okay, so if you don't subscribe my channel, then kindly subscribe it and share it to your friends, neighbors and relatives to get latest updates. Okay, thank you.